Mm. Good morning, honorable teacher and my dear classmates. Welcome to our presentation. Today, on behalf of my group, I will be presenting on phenolic acid, focusing on their structure, biological function, and diverse commercial application. I am Jannatul Noor, and my group mates are Sharika, Alpona, and Naki. Let's dive straight into the world of this emerging molecule. To begin, what are phenolic acid? Simply, they are aromatic compounds containing a benzene ring, at least one hydroxyl group and a carboxylic acid group. In plants, they serve as crucial secondary metabolites. Structurally, we classify them into two major classes. Firstly, hydrobenzoic acid, which have a carbon 6 to carbon 1 skeleton. Example of hydrobenzoic acid are gallic acid, vanillic acid. Secondly, hydroxynamic acid, which have a carbon 6 to carbon 3 skeleton, like caffeic and ferulic acid. Now let's look at the actual molecular framework that drives their reactivity. The high biological activity of phenolic acid is determined by four key structural components. The benzene ring provides structural stability. The hydroxyl group is the secret behind their antioxidant capacity. And the carboxylic acid group allows them to easily form ester and conjugate with plant sugar. And the side chain which differs between the benzoic and cinnamic classes. Specifically, the double bond in the carbon 6 to carbon 3 propenoate side chain of hydroxynamic acid allows for resonance stabilization, making them exceptional radical scavengers. Let's check some key compounds and where we can find them. The table summarizes the key compounds we regularly encounter. For instance, gallic acid found in green tea is a famous antioxidant. Ferulic acid, common in cereal grains, is widely used as a UV protectant. And chlorogenic acid, which is abundant in our daily coffee, acts as a potent hypoglycemic agent. When we look at our daily dietary intake, beverages like coffee, tea, and red wine contribute the largest share at 28%. This is followed closely by cereal and grain at 22% and foods at 20%. This data highlights that phenolic acid are highly bioavailable in our everyday diets. But what actually happens on a cellular level when we consume them? The most celebrated function of phenolic acid is their antioxidant capacity. They neutralize dangerous reactive oxygen species by donating hydrogen atoms or electrons. The resulting phenoxyl radical is highly stable due to resonance delocalization across the aromatic ring. In this essay chart, we compared their relative antioxidant activities. Please next slide is phenolic acid have dual significance. In plants, they act as a natural sunscreens, absorbing harmful UV radiation and serve as key building blocks of lignin, which strengthens cell walls against pathogens. In human, they regulate inflammatory pathway, protect our cardiovascular system by preventing LDL oxidation, and ever trigger apoptosis in cancer cell. Let's look at how this biological function translates into clinical advantage. The therapeutic spectrum of phenolic acid is truly vast. They are cardioprotective, lowering hypertension risks by up to 15 to 20%. They are anti-diabetic, as chlorogenic acid improves insulin sensitivity. They are neuroprotective, specifically uh, ferulic and phenolic acid prevent amyloid beta aggregation, reducing Alzheimer's risks. Furthermore, they act as strong antimicrobials and are used in cosmetics for photoprotection. Due to these incredible health benefits, the commercial market for phenolic acid is expanding rapidly. As shown here, nutraceuticals hold the largest share at 32%. This is closely followed by pharmaceuticals at 28% and cosmetics at 20%. The remaining protein is used in food preservation and sustainable agriculture. Let's look deeper into their specific roles in agriculture and food science. In agriculture, phenolic acid play a massive role in allelopathy, where crops naturally release this acid to inhibit weeds. They also act as biopesticides and enhance stress tolerance in plants during droughts. In food science, they are excellent natural preservatives that prevents lipid oxidation. To conclude, phenolic acid are structurally diverse dietary bioactives that play vital protective roles in both plants and humans, from serving as powerful antioxidants with gallic acid leading the way to bridging the gap between clinical medicine, food preservation, and sustainable farming. They truly represent nature's most versatile molecules. That brings me to the end of my presentation. Thank you so much, honorable teacher and my dear classmate.
তোমার যেটা সমস্যা ছিল, তুমি স্লাইড দেখাচ্ছিলে একটা আর কথা বলতেছিলে আরেকটা, তুমি অ্যাডভান্স স্লাইড আগেই টান দিয়েছো। তো এটা একটা যারা দর্শক তাদের জন্য বুঝতে সমস্যা ছিল, এই একটা সমস্যা ছিল তোমার। আরেকটা সমস্যা যে তোমার যে লেখা অনেক বেশি, তুমি যদি আগের স্লাইডটায় যাও, আগের স্লাইডটা যাও। তোমার ইসে দেখো যে শুরুর দিকে ঠিক আছে, কিন্তু শেষের দিকে যায় কি হয়েছে, লেখা দেখা যায় অনেক বেশি হয়েছে, লেখাগুলো সাইজও ছোট হয়ে গেছে, তাই না? তো এগুলোকে তোমাকে কি করতে হবে, ধরো আমি না হয় কম্পিউটার ডেস্কটপে দেখছি, অনেকেই তো মোবাইলে দেখতেছি। তো এত যখন লেখা হয়ে যায় তখন লেখা হয়ে যায় ছোট হয়, আর ছোট হইলে তারা পড়তে পারে না বা দেখতে পারে না। প্রেজেন্টেশনের উদ্দেশ্য তো খালি তথ্য দেওয়া না, এই লেখাগুলোকে যাতে সাধারণ মানুষ বুঝতে পারে, এই করতে পারে। তো সেই জন্য তো আরেকটু লেখা কমায় এবং সাইজ
কমাইতে হবে স্যার।
কিছু মুখে বলতে পারো, কিন্তু লেখাগুলো এত লেখার দরকার নেই, এবং তুমি তো সব পড়ো নাই, তো তাইলে এতগুলো লেখা দিয়ে কি হবে, আর একটু কি করতে হবে, প্রয়োজনে স্লাইড আর একটু বাড়াইতে পারো, অসুবিধা নেই। এক স্লাইডে না করে 2 স্লাইডে করো, যাতে যাই হোক, যাতে দর্শককে বা শ্রোতাকে তোমাকে কি করতে হবে, আকৃষ্ট করতে হবে। ওকে, থ্যাংক ইউ। নেক্সট 400